Special segments and circles. Segments intersecting inside a circle. If two chords intersect in a circle, then the products of the measures of the segments of the chords are equal. So, AE times EC equals BE times ED. Example 1, we're going to find X. We know that AE times BE equals CE times DE. So now we plug in and solve. So x times 6 equals 3 times 4. 6x equals 12, and x equals 2. If two secant segments are drawn to a circle from an exterior point, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. In other words, AB times the whole length AC equals AE times the whole length AD. Example 2, we're going to find X. So we know that RQ times RP equals RS times RT. We're going to plug in and solve. So 2 times 2 plus 12, because we need the whole length, equals X times X plus 3, which is the whole length. 4 plus 24 equals X squared plus 3X. 28 equals X squared plus 3X. Now we're going to move the 28 over, and we're going to have to factor. So we get X plus 7 and X minus 4. Solve for X for both of those. We get X equals negative 7 and X equals positive 4. But we can't have a negative. So we have X equals 4. If a tangent segment and a secant segment are drawn to a circle from an exterior point, then the square of the measure of the tangent segment is equal to the product of the measures of the secant segment and its external secant segment. So in other words, we have WX squared, which is our tangent line, equals WZ times WY. Example 3, we're going to find X. So we know that AB squared equals BC times BD. Now we plug in and solve. So we have X squared equals 3 times the whole length, so we have 3 plus 9. X squared equals 3 times 12, and X squared equals 36. We have to take the square root of both sides to get X equals 6. On your own. You should get X equals 10. You should get X equals 13. You should get X equals 6.